As long as it all works, I'm good. It's easy as long as the technology holds up.
Yeah.
Okay, so I'm going to open the group meeting quiz and see what we're looking
It's 12 questions.
Oh, yay.
at. Okay.
We're hoping that's an oh yay. I really should be more optimistic, shouldn't I? I will repent. I'll be better.
Well, I took a bunch of notes just hoping writing it down would stick it in my brain better.
I did too.
We'll see. Okay.
Hey.
Okay, so number 3, find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25. So that would be, do you know which formula?
I do. It's m equals z times the sigma over the square root of n.
Okay.
So.
And then we use the number from the chart for 90%, right? A z.
1.645.
Okay.
Okay.
Wait. What?
You know the chart, the level of confidence chart?
Yes, is that in this lesson? I can't find
Yeah, it's 90%. It shows you what the z-score is for 90%, 95%, and 99%.
Got it.
So that's what you plug in for the z. And are you guys using 1.65? Because I've seen them just use that for the 90%. I've seen them just use 1.65 instead of 1.645.
I've been using 1.645. So I don't know.
Okay, I'm just going to use 1.65 and let's see how it comes out.
Okay.
And you can use the other one and see if it comes up the same.
Okay.
Because that's not really much difference.
Yeah.
So.
Okay, so do you know the formula?
Yeah, so it's m equals 2 over sigma over the square root of n, right?
Yeah, so this is
the z-score. Z-score times the standard deviation over the square root of n.
Oh, so I was looking at the wrong one. No wonder that was weird.
This is what I had to figure out yesterday. So you're going to do the 1.645 times 50 over, divided by, or whatever, the square root of 25.
Got it.
Okay.
So yeah, I had the wrong formula. No wonder it was confusing. So it's say factor with the confidence interval. Got it. And it was 90%, right?
Yep.
Yeah. So I just wrote all those what they already equaled on a paper, so I don't have to keep looking them up.
Yeah, that's what I did too.
Yeah, well, they have that chart, so I figure we can use the chart too, right? We don't have to figure it out every time.
Right.
When I had to keep doing that, I was like, why?
So I got 16.5.
And I got 16.45.
Hold on. I'm worried. I'm going.
So do you have to round up then?
Okay, so what did you guys get?
Probably. 16.45.
That's what I have.
And I got 16.5 because I used just the 1.65 instead of 1.645. round to 3 decimal places. Well, I guess we better go with the 645 unless they say otherwise.
Okay.
So you got 16.45, right?
Yes.
Okay. And that's less than 3 decimal places, so.
And if we get it wrong, maybe.
One will. I'll take it for the team, and then we'll figure it out.
All right. Which of the following statements is true? Mu is a point estimator of x bar. Sigma is an interval estimator of sigma squared. X bar is a point estimator of mu. Or sigma squared is an integral estimator of x bar. With the
It's a point estimator.
it's a point estimator, so it's the first or third, but I don't know.
Here we are.
The only one that I wrote down was the x bar x estimates the mean.
So,
Okay.
yeah, it says that the sample statistic would be, what was that question about, or the answer that x bar is a point estimator of mu?
Yeah.
Yeah.
I think that would be right.
Yeah, I agree.
That's the only one that I wrote down. Well, I have S estimates the standard deviation, but there's not a choice of that, so I think it's X bar.
I agree. Okay. Ready for the next one?
Ready to move on?
Yep.
Yeah. Gina wants to construct a 95% confidence interval for the GMAT score. She knows that standard deviation is 113. She collects a simple random sample of size 64 and computes 526. This is information for question 5. What is the lower limit of this confidence interval?
Okay. You got this.
Seriously.
Okay, so we just need to do the minus one,
Yeah.
not the.
Oh, we're gonna have to do both because we have to do number 6, which is upper. So.
Oh, so we might as well just do both.
Yeah.
Okay.
So this would be, you know, the formula for this one. But you,
Is it the x bar minus? Yeah?
Yeah.
Okay.
And that's 95, which is 1.96.
Yep. First, my dogs are gonna start barking.
Hmm. Okay. Do you guys have it? I got 498.315.
That's what I got too.
What?
Try computing it again. Maybe it's a computation number.
Okay, so you did 526 minus 1.96
Uh-huh.
times 113 over 64.
Correct. So then, did you do the multiplication first? Did you do like the 1960 times 113 over 64?
No.
Okay, so that needs to go first. I don't know if you remember, like, please excuse my dear Aunt Sally, where like you did the multiplication division first and then adding and subtracting.
Oh, okay. Yeah, I got it now.
Okay.
498.315,
Yeah.
right? Okay. I'm like, wait, I know what I'm doing.
So then to find the upper, to find the upper limit, do we
So
just add it instead?
Yeah,
Yeah.
so I have to
The
read.
same formula, except there's an addition instead of subtract.
So 526 plus. So it's 553, 685?
Yep.
Almost there. Did you say 553.685?
Yeah.
Okay, yep, that's what I got too. Okay.
Okay.
So number 7, what would happen to the width of the confidence interval if Gina increased the sample size?
So that was on, that was in our homework. And they asked the same question, and the answer is as the sample size increases, the width of the confidence level decreases.
Yeah, because if the sample size increases, then it's more accurate. So you can make the margin of error smaller, so it would decrease, right?
Yes. Yeah, I'm not sure.
It's true.
If you say it's true, I believe you.
And then for the second one, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So as the confidence interval increases, then the width increases.
So let me get this straight. So the confidence interval, so if the width of the confidence interval increases, then our margin of error decreases, right? So our So our sample size decreases. So number 7 is decreased, right?
Right.
Okay. And then so 8, what would be the width of the confidence?
So 8, it increases, right?
Yes.
Okay.
Because you're making a bigger possibility.
Okay, that makes sense.
It's not the same. It's not the same as increasing the sample size because the sample size would make it more accurate. But if you just increase the width of confidence interval, then it just makes it a bigger range of possibility.
Correct. Okay.
Yeah.
Sweet.
I know, it's a little confusing. I really had to think about it.
Yeah. I was getting confused about that for sure.
It's just all backwards. You'd think that a 99% margin, like 95% confidence interval would be, or 99 would be smaller because it means you're more precise, but it just means it's larger so you can have a window of catching what's right.
I think we're just used to too much to hearing, oh, I'm 99% sure this is right.
Right.
Yeah.
Okay.
I can read it.
Okay.
Brightbulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number.
Okay, so that one, let's see.
Do you guys know this one?
Yeah.
Okay.
That's the n equals z times the standard deviation over this margin of error squared.
Yeah. Yeah.
So
95%.
Okay. So did you guys get 16?
16?
Or 15.68?
No.
Sweet.
I got 245.8624.
That's what I got.
All right. Let me. So it's
Back to the old drawing board.
yeah, no kidding. So the formula is n equals z score times sigma over margin of error squared, right?
Yes.
Right.
Okay. So where did I go wrong? So it would have been 1.960 times 400. over 50. Oh, I didn't square it.
You gotta square, yeah, you square the whole thing.
That was dumb. Okay.
So we have to round it up to a whole number.
Yeah, because it's a people.
Yeah.
You can't have part of a people.
Yeah. So 246.
Yep, that's what I got. Even though they go around saying 1.8 children per family or something like that.
Yeah.
So what did you get again?
It comes out
240.
245.8624, and then you have to round up.
Yeah.
Yay, I got it. Okay.
Yay!
So 246.
Okay.
Yay! Okay, I can read this one.
Good luck.
The mean salary of actuaries is mu equals $100,000, and the standard deviation is sigma equals $36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. Yet you set up the hypothesis test with level of significance alpha equals 0.05 and hypothesis whatever.
Yeah. Null hypothesis.
There you go. The null hypothesis equals 100,000 and the
Alternative.
alternative hypothesis equals 100,000. Thank you. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000. Use this information for questions 10 through 12. What is the lower limit of this 95% confidence interval? Okay.
We just did that, right?
Yeah. So we did that in
Fine.
question 5. So
I kind of feel like we should almost have all the information here already. You know what I mean? Without actually doing an equation, but maybe not. Because if okay, so the mean is 100.
yeah.
Oh, maybe not. Okay, so we are going to have to
gonna
figure
solve
out.
for it actually. Because let's see.
So they just gave us all that other information to confuse us, I'm sure.
More like always.
Okay, so it's 90.
Okay. What did you guys get?
8,000 or 88,001.53.
I got 99, but with all the same. I got 99,001.533.
I'm gonna redo my math.
You got 99?
I did, yeah. Let me make sure I'm
Oh.
using the right
Wait.
number.
Oh, that's because I put in. That's because I put in 100,000, not 111.
Oh.
That
Yeah,
makes a difference.
it's supposed to be the X bar, right?
Yeah. Yeah.
So your equation should read 111,000 minus 1.960 times 36,730
730
over 36.
over the square root of 36.
How did I miss that?
Okay.
Got it. Okay.
So it'd actually be 99002,
What are we supposed to round to?
the nearest whole number.
Oh, okay. Yeah, so I guess it would. So it'd be 99,001 or 002.
Okay.
$99,002. Go get yourself a coffee.
Don't leave off the $2.
That's
Important.
right. Makes a big difference.
99 and 1? Wait, what was your result?
Yeah, but then you have to round up.
So it's 99 to 1,000?
99002.
Yeah. Woohoo!
It's not taking a comma. That's weird.
It's what?
Mine's not. I tried to put a comma in there and it wouldn't take it.
Oh, I don't put in commas.
Okay. It just looks weird. That's just like a weird number to not have any commas or decimals or anything. I hate these boxes. I want to, I want multiple choice to see if I'm
Not
even
what
in
you
the
really think.
if I'm even in the right ballpark.
Apparently they thought that wasn't a good idea for learning.
Apparently. Okay, so the next one you just do the upper level, which is
Yeah.
the same numbers but a plus.
Surprised this one is so short today.
Well, remember how we normally they're normally pretty short. We just have tons, we do the homework with it.
Yeah.
Maybe we're getting better because we're doing this faster.
Maybe.
We're
See,
hoping.
there's the positivity.
There you go.
Yay! Ay, ay, ay. Did you guys get 1, 2, 3, 0, 1, 4.8?
No?
Ah, great.
Hold on, I'm almost there. Let me see what I got.
Hey, I could be wrong.
I could be wrong.
That's not a comforting, guys.
Okay, I got 122,998.46.
Yeah, that's what I got.
All right, I'm going to do this again.
And this one's supposed to be whole number 2.
Yeah.
So this one we wouldn't round up, right?
Right.
What? I'm sorry?
We have to round to the nearest whole number, but we're not going to round up on this one.
Oh, okay. Oh, that's why it's wrong. Okay. I put, instead of a period, I put a comma. That would change things.
Yeah, it would.
So you got, what was the number that you got?
120.
Oh, go ahead.
Go ahead.
122998.4 something.
Okay. And you're not rounding up?
It just says round to the nearest whole number, and this is in dollars, right? So it's okay to have. This is not a sample size, so we can just round down because we're just doing regular rounding, is what I'm trying to say.
Yeah. So if it was like a 5 after the decimal point, we would probably round up, but it's a 4, so.
But if it was asking for us to figure out the sample size, we would always round up, is what it said.
Right.
When you're doing the sample size, you always round up, but this is just normal rounding.
So then we're going to leave it 8 instead of 9?
Yeah.
Okay.
122,998.
Okay.
All right, last one.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, X bar is normally distributed, and sigma is known.
And I think it's all of the above.
Yeah.
Yeah.
Yep.
Okay, I can submit it.
Okay.
Brave.
We got one wrong.
Which one?
5.
5.
Did I write that one wrong?